Trigonometry, a word that might sound intimidating at first. Actually, it's a very simple and powerful branch of mathematics. It's a secret language that connects angles and distances, allowing us to measure large and unreachable things with surprising ease. Imagine you're standing on the ground and want to know the height of a tall skyscraper, or a pilot needs to calculate the perfect angle for a smooth landing. This isn't magic, but practical problems solved using the principles of trigonometry. Our goal is to demystify this fascinating subject by breaking it down into simple, digestible concepts. We won't delve into complex theorems, but we'll focus on foundational ideas. We'll bring in everyday examples from homes, schools, and streets. Trigonometry isn't just for mathematicians and engineers, it's a practical tool for everyone. This exploration is for absolute beginners. We'll move forward step by step. The language will be straightforward, with minimal jargon. Our mission is simple: to give you a new way of seeing the world through core ideas, so you appreciate its daily utility. At the core of trigonometry is a special shape, the right-angled triangle. Before we get to ratios, it's important to get familiar with this basic shape. A triangle has 3 sides and 3 angles. An angle is the measure of the turn or space between 2 lines. In any triangle, the sum of the angles is always 180 degrees. In a right-angled triangle, one angle is exactly 90 degrees. This is the foundation upon which basic trigonometry is built. The sides of this triangle have special names. The longest side opposite the 90-degree angle, hypotenuse. Think of it like a slanted roof. The other 2 sides, the legs of the triangle. Let's call one of these angles θ. The side across from θ, the opposite side. The side next to θ, but not the hypotenuse. The adjacent side. Hypotenuse. Opposite. Adjacent. An everyday example, a ladder leaning against a wall. The wall and the ground form a 90-degree angle. The ladder is the hypotenuse. The height on the wall is the opposite. The distance on the ground is the adjacent. If you change the angle, the roles of opposite and adjacent switch. The hypotenuse always stays the same. Now that the sides and θ are clear, let's introduce 3 fundamental ratios: sine, cosine, and tangent. We write these as sin, cos, and tan. A ratio is a comparison of 2 quantities. Here it connects angles to the proportions of sides. If the angle is the same, the ratios remain constant. That's the magic of trigonometry. Sine, sin, θ and sans, opposite, hypotenuse. The kite string is the hypotenuse. The height from the ground is the opposite. Sine connects the angle to the height. Cosine. Cos, ras, adjacent a hypotenuse. It relates to horizontal distance. Tangent, tan, ras, opposite, adjacent. The ratio of the slope or gradient. Remember, SOH ka toe. Example, a ladder is 5 meters long and the base distance is 3 meters. We have the adjacent and hypotenuse. We'll use cosine. Cos θ, irm 35, 0.6. Θ is arc cos, 0.6, 53.1 degrees. Now, given a distance of 20 meters and an angle of 45 degrees, what will the height be? Tan 45 degrees and sub 1, so opposite 20 to 1. Opposite tribe 20 meters. The flagpole is 20 meters tall. This is the same technique surveyors, foresters, and engineers use every day. Simple ratios turn real-world problems into straightforward calculations. Problem, string 50 meters, angle 30 degrees. What's the vertical height? The hypotenuse is 50 meters. We need the opposite, which is the height. SOH. Sin θ and r, opposite, hypotenuse. Sin 30 degrees, 0.5, so 0.5, 0 x 50. Multiply both sides by 50, x or 25 meters. The kite is 25 meters above the ground. Sine, cosine, tangent. These principles are always at work. From GPS triangulation to lighting angles and trajectories in sports, trigonometry is in everything. Look for right-angled triangles around you, shadows, roof slopes, bike frames. Think, sin for height, cosine for the base, tangent for slope or angle. Don't be afraid of calculators. Practice builds confidence. Embrace trigonometry. This new lens shows the hidden mathematical order. A little trigonometry goes a long way.